A four-stroke engine is an internal combustion engine that converts the chemical energy stored in fuel into a force that powers most cars on the road. This engine undergoes 4 steps, also known as 4 strokes, to convert fuel into turning the car's wheels. Essentially, it burns fuel inside the engine, generating hot gases. These gases create pressure that pushes components inside the engine, ultimately turning the car's wheels. Before discussing the strokes, let's review the key components of a 4-stroke engine and their functions. To simplify, we'll focus on a single-cylinder 4-stroke engine to explain all 4 strokes. The spark plug produces a spark when electricity passes through it. The cylinder contains the piston and is where the fuel-air mixture is ignited. An engine can have 4, 6, 8, or more cylinders, depending on the type of vehicle. Regardless of the number of cylinders, each cylinder undergoes all 4 strokes to generate power. The piston is a cylindrical component that moves up and down inside the cylinder, converting the chemical energy from burning fuel into mechanical work. The connecting rod links the piston to the crankshaft and transmits the piston's motion to the crankshaft. The crankshaft converts the piston's up and down motion into rotational motion, ultimately driving the gearbox. The intake valve opens to allow air and fuel mixture into the engine. The exhaust valve opens to release waste gases from the engine. Both valves are kept closed by springs and are opened by cams that push the springs down as the camshaft rotates. The cam belt takes power from the crankshaft and uses it to rotate the camshaft at the top. Now that we understand the main components, let's examine how they work together in a 4-stroke engine. The 4-stroke cycle begins with the intake stroke. The cylinder is a hollow tube with a piston that moves up and down inside it. During this stroke, the piston starts at the top of the cylinder and pulls down by the crankshaft. Simultaneously, the rotating cam opens the intake valve, allowing a mixture of fuel and air to be drawn into the cylinder as if the engine's taking a deep breath. Before entering the cylinder, the carburetor mixes the right amount of fuel with air. The engine won't run efficiently if the mixture has too much or too little fuel. The piston's downward movement increases the cylinder's volume, causing the pressure inside to drop slightly below the atmospheric level, which helps draw the mixture in. This mixture is critical because it will soon be ignited to create the power needed to drive the vehicle. As the piston reaches the bottom of the cylinder, the intake valve closes, trapping the fuel-air mixture inside. After the intake stroke comes the compression stroke. At this stage, the rotating crankshaft forces the piston up the cylinder, compressing the fuel and air mixture into a smaller space at the top of the cylinder. As a result, the pressure and temperature of the mixture increase significantly, making it more explosive when ignited. This step ensures that when the spark plug ignites the fuel-air mixture, the resulting explosion will be powerful enough to push the piston back down with great force. This sets the stage for the next phase of the engine, the power stroke. The real action happens during the power stroke. At the top of the cylinder, a carefully timed burst of electricity makes the spark plug fire, creating a tiny but powerful spark that ignites the compressed fuel-air mixture and causes it to explode. The explosion releases large quantities of carbon dioxide and water vapor, which rapidly expand and push the piston downward with great force. This downward motion turns the connecting rod, which rotates the crankshaft. The crankshaft is connected to the gearbox, which adjusts its rotational speed and torque. This adjusted power is then transmitted to the rear wheels through a drive shaft. This means that the rotation of the crankshaft is what ultimately moves the wheels. The power stroke is the only one of the 4 strokes that actually produces energy to drive the engine, while the other strokes either prepare for or exhaust the byproducts of the power stroke. Finally, the cycle ends with the exhaust stroke. After the power stroke, the cylinder is left with carbon dioxide, steam, and pollution from the burnt fuel-air mixture. These gases need to be expelled before the next cycle can begin. The piston moves back up the cylinder. and this time, the exhaust valve opens, allowing the spent gases to escape through the car's exhaust system. By the time the piston reaches the top of the cylinder again, the cylinder is empty and ready to start the process all over again. Together, these 4 strokes, intake, compression, power, and exhaust, work in a continuous cycle, happening hundreds of times per minute, to keep the engine running smoothly. You might be wondering why engines have multiple cylinders. If only one cylinder did all the work, the engine would run very unevenly because only 1 out of every 4 strokes is a power stroke. This would make the engine's operation jerky and inefficient. To smooth things out, engines have multiple cylinders, usually 4, 6, or 8, arranged so that their power strokes occur at different times. Each cylinder fires slightly out of step with the others, so there's always at least one piston powering the engine. This makes the engine run more smoothly and provides a more constant flow of power. Another reason for multiple cylinders is that an engine generates a lot of heat, especially during the power stroke. If an engine had only one big cylinder, it would get too hot, and the fuel might ignite too early, potentially causing damage to the engine. That's why the engine's total volume is divided into smaller cylinders. This allows for better cooling and more efficient operation. So, that's how a 4-stroke engine works. We hope this animation helped you understand how a 4-stroke engine operates. Don't forget to like, share, and subscribe for more educational content. Thank you for watching.